Hello and welcome to Office Hours by BYK-Gardner. Glad you joined us. My name is John Kowalski. I'm part of the marketing team here. As always, I'd like to welcome you. Our Office Hours format today, if you're unfamiliar, it's a shortened presentation, usually 20, 25 minutes-ish. And then the time is yours to ask questions, to have discussion. So if you do have questions, something going on in one of your facilities or general question or really anything, drop it in the chat and we'll get to it immediately following the presentation. And that chat box should be located in the bottom right-hand corner of your screen. Also, please note we are recording this, so immediately following the presentation, you'll receive an automated link that comes from the marketing team here. Feel free to watch, again, share with colleagues, grab some screenshots, whatever you need. Also note, if you do have a question after the fact, you can hit reply to any of the marketing messages you receive, and my team will route it to the appropriate technical specialist in your region. So there we go. Today's topic, gloss theory and applications. Special presenter today, Mr. Charles Katsuhiro. He is our regional sales manager out on the West Coast. Also online too is our ever popular Mr. Noah Morgan in applications. But Charles, this baby's yours, sir. How you doing today?
Good, John. Thank you for the introduction. And welcome everybody to this edition of Office Hours. As John mentioned, my name is Charles Katsuhiro, and today's topic is gloss theory and applications. So without any further ado, I say we get started. So here's a nice example of, we have incident light that is striking an opaque sample. And we have a couple of things happening here all at once. We have that white light that is being absorbed into the surface. And we know that white light is made up of many colors, all the colors in the rainbow. And that white light is now being absorbed into the surface and it's interacting with those pigments. And what we're getting also is a diffuse reflection, and that's giving us our visible color. And in this case, the visible color is blue. And on the same but opposite angle of incidence, we have what is referred to as specular reflection, and that's our gloss. So how do we perceive gloss? Well, we need a couple of elements. We need a light source or illumination. We need a surface. We need that light source to reflect off a surface. And then we need an observer. In this example here, the observer is the human eye. So we know that gloss is a visual impression whenever we are evaluating a surface. If we evaluate a glossy polished surface, the image forming quality is clear, and we say it has good DOI or good distinctness of image. On the other hand, if we're evaluating a surface that may have some micro scratches, or it's matte, then a lot of that energy, we're losing a lot of that energy. That's going back to the observer. We're getting that scattering of light, so that distinctness of image is now blurred instead of being crisp and clean, just like when you're measuring over a glossy surface. So now that we've talked a little bit about the principles of gloss, let's take a look at this gloss meter design. So it's fairly simple in its principle. Instead of using the natural sunlight as we did before, now we're using a light bulb. Instead of the human eye, now we have a detector. So both the light source and the detector are set at specific angles. There are also lenses that are going to help collimate that light. Both the light source, detector, the lenses, the distance to the surface, those are all set to international standards. Here we have 3 of the defined angles of illumination that are widely used. And for each angle of illumination, there is a corresponding detector. So your 20-degree geometry will be used for your high gloss measurements. Your 60-degree geometry will be used for those semi-gloss measurements, and 85 for your low gloss. So you may ask, why do we need 3 different gloss angles? Well, the purpose is to be able to measure the full range of gloss, from very low gloss to high gloss. The reason we need 3 different angles is shown here in this graph. On the horizontal axis, we have 13 different gloss panels, increasing in gloss from 1 to 13, 13 being the highest, 1 being the lowest. And the steps between these panels are visually equal steps, meaning the visual difference in gloss between the number 1 and 2 panel is about the same visual difference between the 2 and 3 and the 3 and 4 and so on. So equal steps between the panels 1 through 13. And on the vertical axis, you see here we have measured gloss in gloss units. So let's take a look at the measurements taken using the 60-degree meter, and we can see that in the low gloss range, the curve is flat. It's not changing much. It's not until we get into the semi-gloss range that that curve starts to get steep and more linear. Then it's not until we get into the high gloss range that it starts to flatten out again. So what this is telling us is that the 60-degree geometry is ideal for the semi-gloss range, not so much for the low and high gloss range. So let me give you an example to show you why that is. Let's say you wanted to measure the difference between the number 7 panel and the number 8 panel using the 60-degree geometry. When we take measurements, we're seeing a clear visible difference. I think if you look at the scale here, I think we have a difference of about 17 gloss units. Again, visually they look the same, but as we take our measurements, we are getting a nice difference. And if we wanted to measure the 11 and 12 panels with the same 60-degree geometry, we're only getting a difference of maybe 2 to 3 gloss units. Now, keep in mind, the 11 and 12 are visually the same as 7 and 8. They have that same difference. But when we take measurements using 60 degrees, we're not getting much. We're not measuring a very large gloss difference. So we would switch to a 20-degree geometry instrument. And as you can see here on the chart, on the low end, it's fairly flat. You're not getting any real differences. Not until you start getting to the higher range that you start to see that line get a lot more linear. Same with the low gloss. At 85, on the low gloss range, you see that line nice and steep, fairly linear, and it's not until we start getting into the semi-gloss range and high gloss range that it starts to flatten out. So this is the reason for having 3 geometries. So recommended geometries, this is using the baseline of a 60-degree meter. So we took readings using the 60-degree geometry instrument, and if your readings are between 10 and 70 units, then that 60-degree geometry is what you should be using. If you're getting measurements or you're getting values greater than 70, then that 20-degree geometry is recommended. And then anything less than 10, you should switch to your 85 geometry meter. Again, this scale here is not set in stone, but it's a good guide to use. So we talked about gloss units. So gloss units is a scale from 0 to 100, 0 being very low to 100 being very high. In order to define the gloss scale, a polished black glass with a refractive index of 1567 was assigned to the value of 100 across all geometries. As you can see here, across all geometries, and that And all of our BIC instruments, well, all of our BIC gloss meters, I should say, include the black glass with a refractive index of 1567. If you take a look at this chart here, you can see that if you have more or less, if your refractive index increases or decreases, you will get different gloss values. And that's because different materials will absorb energy differently. So something to keep in mind. Here's a good example of that. Here we have a set of clear-coated panels. These are high-gloss clear-coated panels. Visually, they are the same brilliance, but they are made up of different materials. One is a single component and one is a two-component clear coat. Although they look the same, when we measured them, we get a difference of 9 gloss units. So again, they look the same. We took a measurement using a 20-degree gloss meter, and we're getting a difference of 9. Again, it does not correlate to the visual. So very important to keep in mind if you're taking comparative measurements to ensure that the materials that you're comparing are made up of the same material. So here at BIC, we have our tri-gloss meter. You can measure or you can display multiple angles. Yeah, you can display one angle, 2 or 3 different angles. It measures everything from low gloss to very high gloss surfaces with an expanded measurement range of up to 2,000 units. So here's a case study of a coil coating system. This is a weathering test. We have 2 sets of panels here. The first set of panels was measured using a 60-degree instrument, the second set using a 20-degree. As you can see, on the first set of panels, using a 60-degree instrument, there's not a whole lot that the story's telling us up until around the 200-hour range. We start to see it drop down. And then once we get into the 250-hour interval, we see a steep decline. But what we should have done is measured with the 20-degree geometry because, well, again, we are starting at a higher level of gloss. And as you can see right away, around the 100-hour interval, we see a steep decline in panel B. And then it starts dropping even more at the 200 and 250 hours. So that 20-degree geometry, because we did start at a high gloss level, it's really giving us a true story of what's happening with that panel. So again, just another example of why it is important to use the correct geometry to get the full story. So your paints and plastics will absorb light differently than will your substrates such as metals and aluminum. Your paints and plastics will typically top off at 100 gloss units, where metals and aluminum, which are very highly reflective, will reflect all of that energy. So it's important to have an instrument that has an expanded measurement range of at least up to 2,000 units. So measuring gloss on a curved surfaces is possible, but it's only comparative. And that's because we lose a lot of that energy. There are ways around this. At BIC, we do have a small aperture gloss meter that's used, that you can try to measure those areas on that surface. Also, customers will sometimes build a jig that'll support the instrument to measure just where they want to, that way they can keep the measurements the same all the time. So ideally, you want to measure on a flat surface because you want all that light reflected back into the detector. Again, when you're measuring on a curved surface, you're losing a lot of that light's being scattered. It's not reaching the detector. So your values can be skewed. So it's really good to take multiple readings to be able to compare and make sure you're getting the right values. So it is possible. And then measuring on transparent samples. We have a lot of customers that that have this sort of application. And the one thing that's very important is if you're taking comparative measurements, it's important that your samples are of the equal sample thickness. You're going to have that light that's going to bounce around that sample, and it's going to skew your values. And also something that's very important is if you are measuring over a transparent sample, you want to have a background that has zero reflectance. So the one thing that we recommend is a material such as a black velvet. That way you're not getting, you're not getting any light, you're not getting any light bouncing back from your background. So your background is going to be very important. And again, if you're taking comparative measurements, you want to make sure your sample thickness of all your samples are the same thickness. So that's it. This was a short presentation. I'm going to hand it back to John.
Short but important. Thank you. Thank you, Charles. Yeah, and we got Noah. He's one of our application specialists. His email's there. Jot that down. Feel free to ping him directly. Hope that's okay, Noah. I'm sure it is. So if folks questions, keep them coming, drop them in the chat, and we'll get to them. I have a couple here ready to go for you, Charles. How do factors like surface texture, transparency, and substrate affect gloss readings, and how do we, or how can we account for these variables?
So I did hear surface texture, and what was the other?
Surface texture, transparency, and substrate. How do they affect gloss readings?
Okay. Well, if we go back here to I'll go back to this one here. So your surface texture, again, if you're measuring over texture, you're going to get that light that isn't going to fully reflect back to the observer. So that texture is going to break up that light source. It's going to scatter that light source. So you're not going to get a true, I shouldn't say true, but it is going to change your value again, because you're losing a lot of that energy. So surface is definitely going to play a factor in your gloss values. What was the other one again, John? The first one?
Transparency.
And transparency, just like the last slide, a transparent sample is going to be, you're going to have light bouncing around that sample itself. So it's really going to screw your values. So it's important to have a background, using a background that is non-reflective. That's going to give you your better values.
Okay, like you mentioned the black velvet or anything black matte, something like that.
Yeah, something that isn't gonna reflect light back. So something like a black velvet, anything that's that will not reflect light back to the detector is gonna work.
So if you're not able to measure a true value of the gloss due to something transparent, surface texture, is that where you do your comparative measurements, multiple times, then take the average, or how do you account for that?
Exactly. So if you want to take comparative measurements, you want to take as many measurements as possible. So even if your standard, for example, is not, let's say, ideal, it's your standard, and so you want to compare that to the rest of your samples. So you want to take as many measurements as possible when dealing with these situations here.
Perfect. Next question here. My company produces packaging film, often for the food industry. We typically measure gloss on transparent film that's 3 mil thick or less. Do you have recommendations or best practices? Again, kind of back to what you said.
Yeah. Again, if you're measuring anything that's transparent, you're going to need to have some sort of background behind it in order to get that, in order to be able to measure that gloss. Because without it, that light is is going through the transparent material. You're still going to get a value, but it's going to be a skewed value versus applying a correct background.
Okay.
I'll jump in here too. I'll say, especially with transparent products, making sure you measure and compare the same thicknesses is also pretty important too, because you measure different thicknesses. Let's say a 6 mil thick piece of transparent material versus a 3 mil thick piece of material. Because of the reflections that you're getting off of both the surface and the bottom of the surface of that material, because of the thickness, you'll get different results. So it's always important to compare apples to apples. In that case, it would be comparing the same thicknesses to the same thicknesses. So that's always something to keep in mind when you're doing that type of measurement.
Nice. Another one, how does film build affect gloss readings?
Film build. It depends. It's really depend on the material itself. For example, if we're talking about a clear coat and you have too much clear on a product, let's say your correct film thickness should be 3 mils, but let's say you have 6 mils. Adding too much film build might create some sort of haziness on the top coat, some sort of solvent pop that's going to create a haze in the clear coat. So it can affect it. Again, it's going to depend on your application, what your standard for mill thickness is. So exceeding that mill thickness may have an effect on your gloss.
Okay, good. Someone chimed in here. Continuous mode is another way to average a lot of measurements over a large sample. One of our other sales folks chimed that in. Thank you, Greg. Let's see, another one. Can we measure haze along with gloss?
You can measure haze. There are instruments that will measure haze and gloss. We had an instrument. Maybe you can help me here, Noah. I'm not sure if that instrument is available anymore.
Yep. So there was an instrument that we used to have. It was called the haze gloss, and that would measure a combination of both haze and gloss. If you think about reflection haze in this case, it's more of at the specular angle. So how you would perceive gloss, you sometimes have an effect where it's a slightly hazier instead of a very clear reflected image. So think of like a mirror versus a reflected image where you can't necessarily make out you can make out the shape, but it's not as clear. It's more fuzzy. That's where you get that reflection haze. So we have some instruments that can measure that as well.
Okay. Are there, in your experience, Charles, or Noah, you too, but we'll let Charles go first here since this is his webinar here. Have you experienced any unique applications out there or unique challenges that you had to work through to get accurate gloss readings? Anything come to mind?
The one that comes to mind is we had a customer that wanted to measure clear plastic bottles, and these plastic bottles were textured. So finding the entire bottle was textured. So finding the correct background, working with them on correct sample sizes, that type of stuff. That's probably the one that comes to mind when it comes to measuring gloss. For the most part, I've been pretty fortunate where most of the applications that I get involved in are pretty straightforward. But I have to say that one there kind of threw me for a loop, and have looking for ways to get them the best comparative measurements throughout their production. So but again, I've been fortunate where most of it has been pretty straightforward.
Nice. Noah, any unique applications or challenges that you faced?
Oh yeah,
you can remember
many of them. Some of the cooler ones are they take into account a lot of the things Charles mentioned, like best practices. Where you have something like the coat on a rifle barrel was one of the interesting ones. And in that case, we had to Obviously, you have the curvature in that. So we had to use a smaller aperture model that was able to not take into account as much as the curvature, but also create that fixture like Charles was mentioning, so that you can measure in the same location every time, so you're ensuring that every measurement is comparable to one another. So you take into account those practices, which is important. Some other cool ones are, again, samples that had a lot of texture in them. And so with those, it's best to average out those measurements. But you can go one of two ways: either average out a lot of measurements across the sample to get a representation of what it looks like. Again, for comparable relative values, or you could go the route of just a fixture and making sure one specific spot is measured and compared each time. But either works in that situation.
Nice. Got a question in here. How do you measure gloss on wet paint or of wet paint? Yeah. Okay. Yeah. Yeah.
So I guess we would need to use some sort of accessory that would hold the liquid under the instrument itself. Again, we do have benchtops that can do this, but as far as a handheld, I haven't tried it yet with a handheld. But again, we have some other instruments that do have those accessories.
Yeah, and you want it consistent, like whether you're measuring gloss, color, texture, whatever, all of our instruments, as long as you set in place your consistent practice and standards. So it's apples to apples comparison from one plant to the other, one shift to another.
That's correct.
And measuring in the exact same way, using a jig, using one of the accessories. I hear that. That's big for every one of these webinars on every one of our instruments. So good. Emily, does the instrument allow you to change the light source illumination? For example, D65. That question just came in.
Yeah, that's a great question. I can answer this one. For the most part, in gloss, you don't necessarily have a big difference on let's say reflection as far as luminance goes. So you're standardized mostly on one illuminant. I can't remember off the top of my head which one that is. I assume it's D65, but for the most part, interchangeably, you can use different light sources, and you usually get the same result because all it is just light reflecting off of the surface.
Okay, good. Hope that answers your question, Andy. Another one here. How often do gloss meters need to be calibrated?
Well, typical interval for calibrations is about a year, 12 months. Sometimes we go out maybe 18 months. The instrument itself does come again with a polished black glass, and so that when you turn the instrument on, it'll tell you to calibrate, and it'll self-calibrate itself. But what I was just describing was the calibration done at our headquarters, or when we have a service technician come out and service your instrument. But when you turn the instrument on, it will calibrate itself. It does have that calibration tile, so it'll self-calibrate. It'll ask you when you calibrate.
Nice. No, I just sent you a follow-up on Teams too. I think it's on the wet paint question.
Mm-hmm.
Is this in addition to the drawdown template?
Yeah, so this is almost like a different type of let's say application. So you could also go the route of a robotic system. So we have some robotic systems in use of a couple different of our customers that that use it. But essentially, it's a robotic gloss meter. So it works off of either an XY table or a robotic arm. And you can choose the option of bringing samples to the instrument or to the aperture, or bring the aperture to the sample. But the way it measures is it's a non-contact gloss measurement. And so you don't have to risk getting the instrument covered in material because it takes the measurement non-contact. It's roughly about 0.2 millimeters off of the surface. So it has sensors that detect how close it is to make sure each of those measurements are always going to be the same no matter what. So that's another good option if you're testing wet surfaces, a good non-contact method.
Yeah. Good solution. Great solution if you want to get into the robotic stuff.
Absolutely.
Cool. In your experience, how does gloss impact the color measurements using multi-angle spectrophotometers?
So it depends. So so gloss will affect it depending on the type of geometry that you're using. So there's two different types of geometries to measure color. We have the 45-0 and we have the sphere. So when measuring with a 45-0 instrument, that gloss is part of the measurement. So it's going to measure color as we see it. So it will affect your values as where with a sphere instrument, it's taking that gloss and the texture out of the equation and it's reading pure pigment. So it's going to depend on the type of geometry of color instrument that you're using.
Sure. And that's a good point too. If anyone out there has, something unique or it's something you just are unsure of how to go about measuring it, testing it, setting up a process, we're here to help. People send in samples all the time to Noah and his team, Charles and our regional sales folks all around the country and world. They can visit your facility, evaluate what you're doing, and help work with you to develop some best practices as well. So keep that in mind. If you run into any challenges, don't struggle yourself, reach out and we can help. Okay. How do temperature and humidity affect gloss during application, and what precautions should be taken to minimize these effects?
So gloss during application, or I'm sorry, how temperature and humidity affect. Yeah. No, I'm going back to the history that I have. So I came out of the refinish industry and worked as a painter for a couple of years, and so I know that in spraying vehicles with an automotive clear coat, if the temperatures are too high when you're spraying, it will affect application. Meaning you may have some dry spray, or you might have product that's drying a little prematurely before the bake cycle begins. So all of that can affect gloss. Humidity will also create, if you're coating material, let's say outdoors, and let's say you're for example, architectural coatings. If you're coating outside when the humidity is high, you're going to get you may get blushing in the paint. So it is going to change. You can get dullness in the paint. It may not dry. It may take longer to dry. So you are going to get different sheens. It's not going to be as how can I say? It's not going to. It's going to be. You're not going to get the same finish overall. So temperature, humidities will play a role in your gloss values.
What ways are there, precautions to take to minimize these effects, or just simply take note of it and don't paint when it's high humidity?
Yeah, I think it's important just to, whatever type of product or application that you're using, is to understand the product, understand when and how it should be used. Is if you step outside those specifications, that's when you get into trouble. So no matter the type of industry, the type of application or product, it's always important to stay within those, specified requirements of that material.
Yeah, no, great advice. Great advice. When measuring gloss on plastic, does the temperature of the sample play a role in specifically in repeatability? That's a good question.
It can, and one of the, it definitely can. It definitely can play a role. Noah, maybe you can explain the science behind the material changing when it gets warmer. The one thing I do know is with our instruments, with our big gloss meters, one of the big advantages with them is that they're very temperature stable. So, you can take measurements inside the lab or out in the field, and if you're measuring the same sample, our meters are going to give you the same value. So the instrument itself is temperature stable. Again, I'm not 100% sure on the material itself and the science behind if it changes its gloss, whether it's, hotter or colder, if it changes temperatures. Noah, perhaps you have the answer on that one.
Yeah, sure thing. So depending on materials, some materials can change actually with the microtextures, which directly affect whether it's matte, semi-gloss, or high gloss. So you'll notice differences usually in the drying aspect. So as whatever that coating is as it dries, that can play a huge role into what the outcome is eventually for gloss. But like Charles said, once it's dried, you don't see much changes unless it's a very significant change in temperature or humidity.
Okay.
But a lot of instrumentation or electronics you can think of are affected by temperature and gloss, or not temperature and gloss, but temperature and humidity. And so in the past, it'd be an issue where you'd have to recalibrate often, whether you're going outside or inside, taking measurements. But like Charles mentioned, with these more advanced technologies that are added to these instruments every year, you're able to mitigate that effect. And that's one of the advantages of this equipment.
Yeah, pretty cool stuff. Another one, can you go back to the three main geometries slide using gloss measurement, and when would each one be appropriate? Can you review that again?
Yeah, let me get back here. So at the semi-gloss range, that's between 10 and 70 units. The 60-degree geometry is what's recommended. Anything greater, and then once we get anything past 70, greater than 70, into the high gloss range, you want to use your 20-degree, and then anything below 10 units is when you would choose your 85-degree geometry.
Okay, nice. And I remember you mentioning this prior. This is a guidelines, nothing set in stone. It depends on application, depends on substrate, a lot of variables there. But as a guide, this is where you start.
Yes, definitely. And a lot, very widely used is that 60-degree geometry. Customers throughout different industries will simply use a 60-degree instrument. So again, this is a guide. This is what's recommended if you want to get the like I say, the true story of what you're seeing, something that's going to correlate better visually. But that 60-degree geometry is very widely used throughout various industries.
Nice. Thank you. Other questions out there, folks? Drop them in the chat. We have a little bit of time left. Also, like I mentioned, you're going to get a recording of this. Feel free to hit reply with any questions you might have after the fact, or just to reach out and say, hey, this is what we're doing. We'd love your opinion on it. Our regional folks like Charles, applications like Noah, they're here to help and assist and to really dial in your best practices to ensure you're getting that, apples to apples comparison and data over time, just to streamline everything. If there's no final questions, Yeah, I'm not going to hold you. We're all busy. But Charles, any parting words or advice, words of wisdom for our audience regarding gloss theory and applications?
Parting words, I would just say, going back to the slide here, take, using the 60 as your baseline, take your measurements. If you fall within those, values, you have the recommended geometry. So I would definitely stick to this guideline here if you want to get,
Yeah.
true values. And if you're measuring stuff with curves or, transparent materials, anything outside the norm, you want to take as many measurements as possible, to get your standard, to get, to get that average, to get that, it might not be the true standard, but it's your standard. So take as many measurements as possible.
Awesome. No, great advice. Appreciate it. Thank you, Charles, for sharing your knowledge with us. Thanks, Noah, for the support. Thank you, everybody out there, for joining us today. We look forward to seeing you on future BYK-Gardner Web seminars. Have a great rest of your day.